Section number 59, the last section of their basic algebra video, is entitled Word Problems Involving Quadratic Equations. The first word problem will be the following. Suppose you know, or come to know, that the area of a square is, what's a good answer, is 26 square inches. Find each side. Find the length of each side. So you have a square. We'll call each side x, or some people use s, I guess, for side. And you know the area inside is 26 square inches. The area is obtained by multiplying side by side. And you get 26 square inches. Then x will be the square root of plus or minus the square root of 26 inches. Okay. Now, it's ridiculous for the length to be negative. Mathematically, if x squared is 26 square inches, then x is plus or minus the square root of that. But x represents the length of a side of a square. What would it mean for the side of a square to be, say, negative 3 inches? It would be silly. So we get plus the square root of 26 times the square root of inch squared. But the square root of inch squared is inch. Each side is the square root of 26 inches. That's the length of each side. This is a quadratic equation. You have x squared minus 26 equals 0, where the b value is 0. It's an incomplete quadratic equation. But nonetheless, it really was quadratic. And if somebody asked me to solve that problem, I never would have thought of or mentioned, oh, this is a quadratic equation problem. You could have even used the quadratic formula. Okay, number 2. You come to know that the length of a rectangle is 3 times its width. And you're given the area. Suppose I tell you the area is 300 square feet. The instructions are to find the length. Okay. Well, the length of a rectangle is L, and its width is W. So you have 3 times W. You have L is 3W. L is 3W. Okay. So let's draw a little picture. Here's the width and the length. But the length is 3W. Okay, and you should know that area is side by side, length times width. One side times the other side is 300 square feet. I would divide by 3 right away. And this will give me 100 square feet. So W squared is 100 square feet. So W is equal to plus or minus, but then again, W must be positive. The square root of 100 is 10. The square root of feet squared is feet. Remember, the square root of y squared, you do 2 into 2 is 1. So the answer is just y to the 1. Nothing, the remainder is 0. Nothing goes underneath the radical. y to the 0 does, which is 1. The square root of n squared. Well, inches, instead of y, you have inches, just inch. The square root of y squared was y. Well, then the square root of in squared is in, inch, or feet in our case. The answer is, well, W, we just learned, is 10 feet, and the width, the length, is 3 times 10 feet, which is 30 feet. And yes, the length really is 3 times the width, and the area is 10 times 30, which is 300. Feet times feet is feet squared. So we did what? 10 and 30 is the answer. In terms of the word problem, converting the words to an equation, or translating the words to algebra, don't panic. The length of a rectangle, L, means equal 3 times the width. Oh, that's W. L equals 3W. L equals 3W. You can handle that. You guys panic. You just panic when you see words. Well, you say you don't like math. Well, you have, because math has numbers and all. But when you see words, you don't like that either. Some reasons. Get over it. You can do it. Okay, the next one. Suppose you come to know that a number is equal to its reciprocal plus 4. Well, a number, that's n, is equal to means equal. And if you didn't like n, you can use x. It's reciprocal. A number is equal to its reciprocal. When it says it's reciprocal, it means the reciprocal of the number. N is n over 1. So its reciprocal is 1 over n plus 4. A number, n, is equal to, that means equal to, its reciprocal is 1 over n plus 4. There it is. A number is equal to its reciprocal plus 4. I can read it backwards. There's no way I have this wrong. There's absolutely no way I have this wrong. Okay, now the math starts. Now I can make mistakes. N is equal to 1 over n plus 4. This is a quadratic equation. You multiply everything by n. And I'll get n squared equals to 1 plus 4n. And bring everything to the left. You get n squared minus 4n minus 1 is 0. Now you try to solve this. Since it's n squared, it'll be n followed by a number times n followed by a number. Don't worry, oh my, it's not x's, it's n's. I mean, you want it to be x's, it's x's. I crossed the n's, now they look like x's. Let's actually do it with the same color. Now they look like x's. It doesn't matter what the variable is. What matters is I want two numbers that add up to, that multiply out to that constant -1, so it add up to -4. And the only pair of numbers that I can think of that multiply out to -1 are -1 and 1. That means I have to use some other technique, like the quadratic formula. Now, the big difference here is the variable is not x's, it's n's. So instead of saying n equals, instead of saying x equals, I say n equals. And everything else is the same. Negative b plus or minus b squared minus 4ac all divided by 2a. That is, n is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And a is 1, and b is 4, and c is negative 1, and it does equal 0. So a is 1, b is negative 4, and c is negative 1. So negative 4 is 4, plus or minus the square root of 16, negative 4 squared is 16, and 4 times 1 times negative 1 is negative 4. So that's going to be 20 over 2. So we have 4 plus or minus the square root of 20. But the square root of 20 is the square root of 4 times the square root of 5, all over 2. So we get 4 plus or minus 2 radical 5s all over 2. Okay, one last line I need to use. Let me do it right here, please. From 4 plus 2 square root of 5, I can factor out a 2. Plus minus, excuse me. I can pull out a 2. 2 times 2 is 4, plus minus. 2 times radical 5 gives me 2 radical 5 over 2. And the 2's will cancel. And those are my two answers. 2 plus or minus radical 5. If I take the reciprocal of those numbers and add 4, I'll get back the original numbers. Now, let us check that. Let us be bold enough to go and check this. Remember, the number, let's say 2 plus square root of 5, is equal to its reciprocal, plus 4. So I'll mess with the right-hand side, because the left side is rationalized. It has no radicals in the bottom. Let's just look at this number a little bit more clearly. Let's look at this number. It equals 2 itself times 1. 2 minus square root of 5. 2 minus square root of 5. So the top is 1 times 2 minus radical 5, which is just that. Now the bottom is difference of squares. You get 2 squared minus square root of 5 squared, which is 5. The bottom is negative 1. That means the whole thing is this. This is negative 1. I multiply the top by negative 1. I get positive square root of 5 minus 2. I multiply the bottom by negative 1. I get 1. And dividing by 1 I don't do. Okay. So this number is really this. So that becomes the square root of 5 minus 2, that's this number, plus 4. Well, negative 2 plus 4 is 2. So you have the square root of 5 plus 2, which is exactly what we have on the other side. It did check. Square root of 5 plus 2 is the same as 2 plus square root of 5. I took the reciprocal of this number. This is what I got. And then I added 4, and amazingly, I got 2 plus square root of 5. And if you did it with the minus, you'll get the same exact thing. 2 minus square root of 5 will equal 2 minus the square root of 5. So there are two numbers. Now when you take their reciprocals and add 4, you get back your number. I'm thinking of a number. If you take the reciprocal and then you add 4, you get back the same number. At this point, you all should say 2 plus or minus the square root of 5. Okay, the next problem actually is the last problem. If the product of two consecutive even integers is increased by 4, the result is 84. If the product of two consecutive even integers is increased by 4, the result is 84. Now, two consecutive integers. If I let x be one of them, then the next one will be x plus 2. And it says, if the product of two consecutive even numbers, or forget if, the product of two consecutive even integers. Well, here they are. The product is increased by 4. You add 4. The result is 84. Okay, so x times x plus 2 plus 4 is 84. I hope you realize that that should be 80. Because 80 plus 4 is 84. Take away 4 if you insist, but you're going to get that. You're going to get that this is 80. 84 minus 4 is 80. So a number times 2 more is 80. Well, can you think of two numbers that multiply out to 80 where one is 2 more than the other? And they even told you they're even numbers. You can try 2 and 4, 4 and 6, 6 and 8, 8 and 10, yeah, that's it. Or negative 10 and negative 8. Those are the two answers. X can be 8 or negative 10. So you just review to use algebra. You get x squared plus 2x is 80. You bring the understood positive 80 to the other side of the equal sign as negative 80. Now, you almost have to solve the same type of problem, same level of difficulty of problem that I just did right here. I would love two numbers that multiply out to 80 that add up to 2. Numbers that multiply out to 80. 1. Well, if they add up to 2, the two numbers have to have different signs to end up being a negative. If you want, when you add numbers with different signs, you keep the sign of the larger number. And since you want the sign to be plus, I'll let the larger number be positive. Negative 1 and positive 80, negative 2 and 40, negative 4 and 20. Want the sum to be 2. Negative 8 and 10. Well, there it is. Those multiply out to 80 and add up to 2. So those are the two numbers that go next to x. Negative 8 and the understood positive 10. So either x is 8, the product is 0, or x is negative 10. Now, if they ask you to find the two numbers, remember, we let x equal the smaller even integer, and x plus 2 is equal to the larger even integer. Well, if x were 8, then x plus 2 is 10. And if x is negative 10, well then x plus 2 is negative 8. And there are your two answers. One pair of numbers, 8 and 10, and the other pair is negative 10 and 8. But we already had them without using algebra. But nonetheless, we had to use algebra. Okay, folks, I hope this completes their algebra. algebra video, the basic algebra video. I hope it was helpful. If you have any questions, you know how to contact me. Just go through, I guess, eBay. And if you want any other videos, they're up for sale. In fact, you can purchase any other video by going to my website, www.mathtutor1.com, and you go to the page that actually has the listing of the videos. Videos.htm, and you can purchase your videos right there. Right now we have a free algebra video, as you probably know. We have the basic algebra video. We don't have intermediate algebra yet. I'll work on that soon. We have a trigonometry video. We have a pre-calc video. And we have Calc 1 and Calc 2. Calc 3 is coming. And we also have a study video for the practice exam. I think it's 0061. Only the math class. And this is to become a high school math teacher. Okay, once again, I hope you liked the video and good luck with your basic algebra.